Let's take a look at this series, summation of 1 over n to the 2/3 plus 1 over n to the 3/2 as n goes from 1 to infinity to determine if this converges or diverges. We're going to do this in two different ways. The first way is certainly the shortest and the way that I would recommend. Method number one, we observe that summation 1 over n to the 2/3 diverges. Now, why does that diverge? It's a p-series with p is equal to 2/3, which is less than or equal to 1. And that summation 1 over n to the 3/2 converges. That converges because it's a p-series with p is equal to 3/2, which is greater than 1. Okay, so this diverges, this converges, that attempts to add the two together. And one of our theorems is that if we have a divergent series plus a convergent series, like this term by term, the resulting series diverges. Therefore, summation of 1 over n to the 2/3 plus 1 over n to the 3/2 diverges. Yep. And that's really it. We have a divergent series plus a convergent series. If I try to add the two together, the result diverges. All right, so that's the first method. The second method also works. It is a little bit longer. I don't necessarily recommend this, but for the sake of the review, I will include this second method. And you may have done it this way on your own. So let's use the limit comparison test. All right, now what should we compare this to? Which of these is bigger? Well, as n gets large, n to the 2/3 is smaller than n to the 3/2, which means that 1 over n to the 2/3 is going to be bigger than 1 over n to the 3/2. This term is going to be bigger than this term because the denominator is smaller. So let's take a look at the limit as n goes to infinity of the original nth term, 1 over n to the 2/3, plus 1 over n to the 3/2, divided by the bigger of the two, 1 over n to the 2/3. Okay, so this fraction divided by that fraction, that's equal to 1. And then this fraction divided by this fraction is n to the 2/3 over n to the 3/2. Okay, so let's simplify that. Limit as n goes to infinity of 1 plus 1 over n to the 5/6. 5/6 is 3/2 minus 2/3. And that is going to be equal to 1 plus 0, which is 1. So as n goes to infinity, 1 over infinity, that goes to 0. Now, the value of 1 is not so important. What is important is that it is something between 0 and infinity. And so therefore, since summation 1 over n to the 2/3 diverges, and the reason it diverges is that it's a p-series with p is equal to 2/3, which is less than or equal to 1. The original series also diverges. So we compute this limit here. We get a result that's between 0 and infinity. And so if we know that this one series diverges, the other series diverges. Had this converged, this would have converged. So they both diverge or both converge. We know that this one diverges, and therefore the original one as well diverges.